We are going to show you how we can program 8051 microcontroller making use of the software that is Keil Microvision 5 that's available with me on this my system. So let us start this Keil Microvision 5, and in this I have already some program written over here. I want to start a new program, and in this let us start a new program by the name toggle switches, toggle bits of the microcontroller. We go to the project option. In project option, we select new microvision project. Started, we give some name to it. Let us name it toggle. Let's call it toggle. The project name is toggle, TOGGL, toggle. Okay, save. Then there is an option coming, select the device for the target. Then where we want to burn, in which device, which microcontroller we are using for programming. Let us say 8089 S52 is one of the microcontrollers manufactured by the microchip. I am selecting here. We get the description of this microcontroller, how many ports are there, how much flash memory is there, on chip ROM, all information we get. Then we click on the OK. We don't need any startup file for this, no. Then after this we start a new file. In order to write the code, we start a new file, and for toggling the bits of the microcontroller, toggling the bits of the microcontroller port, I am writing a program that is starting with the org, that is the assembler directory org 00h. H means it is in the hexadecimal format, the data is entered in the hexadecimal format. Then move R0, hash. Let us put the data 55, because 55 in 55 we have alternate bit 0 and 1. Then after that I am moving this data to the accumulator using the instruction move A, R0. Then shift that data or display that data on the port. Let us say port 1. Move P1, A. Whatever the contents we have on the accumulator that gets displayed on the port 1. Then in order to see this result, let us put some delay of, let us take the delay of 1 second. A called delay. Then after delaying, we complement the contents of the accumulator using the instruction CPL A. Then sjump. I am using the sjump because I am going to repeat this program again and again. Sjump, let us say here the label is here. Sjump here comes over here, that is the move contents of accumulator to the port. Here I am using here HER here, then sjump here. This is the program. So what the program says, move R055. 55 means 0101. Alternate bit is 0 and 1. That data gets displayed on the port A. After that goes to the accumulator. The contents of the accumulator then go to port 1. Then we introduce some delay. After delaying, we complement the contents of the accumulator. Then again we go to this for displaying the data on the port 1. Move A to P1 using the instruction sjump here. Now here in A called delay, we have to write some program to introduce appropriate delay. Let us say I am using this delay subroutine of 1 second. I am using the registers for this purpose R2, R3 and R4. So the program is delay. So move R2, let us put the data. I have calculated this data that I am entering in the registers. It is as per the this 1 second delay. 10, then move R3. The data here entered is 180, then move R4, 250, then I am using the instruction DJ and Z, that is decrement and jump, R4, back, and the back is over here, the label is over here. What does this instruction does? DJ and Z, decrement and jump R4 back. So I have to decrement the contents of the R4 register till it becomes 0. So and the loop will remain here unless and until R4 becomes 0. So when R4 becomes 0, then another instruction gets executed, that is DJ and Z, R3 back. Let us place the label back 1, that goes over here. Back 1, then when it becomes 0, again DJ and Z, R2 back 2, then after that here back 2 is over here, back 2, then this also becomes 0, then return and end. So this is the, after writing this code, we have to save this by the same name, toggle, T-O-G-G-L, toggle, but with the extension, because it is written in the assembly language, with the extension ASM. Save. Do you want to replace, because already we have, I have this, let us give some different name. Let us give some different name to this, toggle 1, save. So it gets saved, and there is this color also got changed, that is I have, now it is in the assembly language. Now I have written it in order to check for errors, if any. What I am going to do is, first of all, I have to add this source file to the target. The target I have generated using the Keil microvision project. So I have to right click on it, add existing file to the source group. So I have to add this file to the target. So here I have to select the file that I am currently using, that is toggle1 ASM. Okay, add, close. We have to close it manually, it does not get automatically closed. So then after adding, so source toggle1 has got added with this target. Then right click on the target 1, go to the options for target 1, click on it, then you can change the frequency over here, crystal frequency 11.0592 is the crystal connected to the microcontroller over here on the hardware. So okay, again go to target, right click on it, options for target, then select the output. So here the option create hex file, click on it, okay. So your hex file got generated. After that, when it gets generated, then what we have to do is, now we have to build the program down. So for any errors and warnings. So here I am getting some error, that is the undefined symbol over here. R0 may I have used it in R0, here R0. Again I will save it, translate it and build. So I am getting 0 errors and 0 warnings. So now my code is ready for burning on the microcontroller. So for that purpose, for burning this code on the microcontroller, I am using one more software, that is the ProgISP. That is ProgISP. ProgISP is over here. ProgISP over here. Here in this, you had to select the appropriate microcontroller that you are using, because we have number of microcontrollers for different numbers. I am using 8089S52. So select it, then check these, verify certain options to be checked and unchecked, verify signature to be checked, chip erase, flash, verify flash. Then we have to connect the USB cable to the USB ASP programmer. If you remove it, it becomes gray. When you connect it, it gets active. So it gets active. Then if there is any some more problem associated after connecting, still it remains gray, then we have to download certain drivers, required drivers for this. Then go to file, load flash. In the load flash, here we have the toggle one. We have to look for the toggle one. We have used over here, that is object and toggle one, toggle port. Here I can open it. Then first of all we have to erase it. First erase it, then click on the auto. The file gets burned on the IC. Now we can see how the result gets displayed. That can be done using the LEDs, or you can use CRO or any indicating device that gives the status of the port and how it gets toggled after every second. Because we have used the delay for 1 second, we can use different delay subroutines for different delays to be introduced between the toggling of the status of the output bits. Thank you. Here we have this 8051 development board. Here in this development board we can program this microcontroller 8051. Here we have a burner, that is the socket is here available. Here we have to insert this. This is the 8051 microcontroller IC. Here you can see the number of this IC is 8089S52 40 pin. So we have to place it on this socket, but ensure that you have this groove on the upper side of this IC should be towards this lever of this socket. So when we place it over here, after placing it, then close it by placing this lever down. Then we close it. Then we have the options for programming this using this port also, VGA, and we have one more, that is ISP burner, that we can make use of this burner, that is USB ASP programmer. Here we have the pins for programming, that is ground, VCC, a clock. Then we have this MOSI, that is the serial input, serial output pins are available. So we have to accordingly connect this to this. If we go through the programming through ISP mode is over here, that the port is available over here, ground, VCC, serial in, serial output, clock and reset. So these pins should match with the pins of the USB ASP, this programmer. Then after matching this, we place the socket over here for the programming of this 8051. So when we place it over here, now we can use this to program this 8051 microcontroller. We have the options for displaying the data, that is the LEDs are available over here. We have 7-segment display over here. The one more option is over here, that is the displaying this data on the LCD display, LCD 16:2 display, that we can connect over here. So motor ICs are connected with, that is we can connect motor over here. Stepper motor we can connect over here. So first of all, let us say one program, that is the toggling the bits of output port. Let us say port 1. What I want to do is that we want to display some data on the port. Let us say port 1. We have 4 ports. Port 0 on one side here, port 0, port 1, port 2 and port 3. Here I am using port 1, that is this port, to display some data. That data gets toggled. That is, if previously it was 1, it becomes 0. If previously it was 0, it will be 1. That gets displayed over here, making use of these LEDs. Now to upload the program in the microcontroller, making use of this USB ASP programmer, we connect making use of this cable, USB cable. We connect it to the USB port of the computer. Then what we do, we connect this to this program, this microcontroller development board to burn this program. When I have already burned it. Now the displaying the contents of the port, I connect this LEDs to the port 1, and the data gets displayed over here. The data, it toggles, that is 5 and AA. 5, when we toggle the bit is 5, then toggled version is the AA. When again we toggle the AA, it becomes 5, because in 5 and AA alternate bits are 0 and 1. So we can also see the data on the port of port 1. If we remove this and see the result on the this DSO also, here on the DSO you can see we have this toggled bits. A square wave is generated over here. So I will reset it. First of all, I will reset it. So here we get a square wave, perfect square wave generated on. If we take one bit, because the bits get toggled. Toggled means to switch between 1 and 0. So that output we can visualize on the this DSO. That we get getting a square wave on each bit of the port we have programmed. So this is we can check it, the result or the output on any indicating device like CRO, or DSO, or making use of the LEDs.